equal to 27 over 8. 27 is the same as 3 cube, then 8 is the same as 2 cube. So 3 cube over 2 cube is the same as 3 over 2 all cube. Are you seeing that? So the average of the first and fourth term over GP is 140. Given that the first term of the series is 64, determine the common ratio, the eighth term, and the sum of the infinite series, isn't it? Now the first thing you need to do is to identify the unknowns of this given progression. You'll be told it is a GP, it is a geometric progression, isn't it? So in a geometric progression, the first term is denoted by A, then the common ratio. The common ratio is denoted by R, then the nth term over GP is given by AR raised to power n minus 1, isn't it? Then the sum, because we need the sum of the infinite series, so the sum of the infinite series is given by A over 1 minus R, and that infinite series is coming from the binomial series, isn't it? So from there, we now go back to the equation and we substitute what is given, isn't it? So in the equation, we've been given the average of the first and fourth term over GP. So you come and say, average of first and fourth term means first term plus fourth term divided by 2, because there are two terms. So if you look at the average of two terms, you add them and you divide by the total now. Isn't it? See, that's how to get the average. So the average of first and fourth term is first term plus fourth term divided by 2, because there are two terms. So you divide by the total number of the terms you are dealing with, isn't it? So this average you'll be told is 140, meaning is equals to 140. Are we together? So you are done with the first statement, where the average of the first and fourth term is 140. Then the second part, given that the first term of the series is 64, meaning you've been told the first term or A to be equals to 64. Then you will now want to determine the common ratio, the eighth term, and the sum of the infinite series. Now from here, we simply do the substitution to simplify, isn't it? So we start with the first equation. We have first plus fourth divided by 2 to be equals to 140. So you can multiply both sides by 2 to get rid of 2 in the denominator, isn't it? So if you multiply both sides by 2, you will get first term plus fourth term to be equals to 280. Then when there is first term, you put the value of the first term, isn't it? The first term is A, isn't it? The first term is A. And the fourth term is, remember the nth term is AR raised to power n minus 1. So when n is 4, we now have fourth term, isn't it? So fourth term will be AR raised to power 3, senior. So that is going to be AR raised to power 3 is the fourth term, isn't it? So from there you can see A is a common factor, isn't it? You can factorize out a common factor. So you have A into 1 plus R cubed to be equals to 280. But we've been given A in the second equation. So the first equation we've simplified in its simplest form. Then the second equation we have A is equals to 64. So we can actually use the substitution method to get R, isn't it? The common ratio, meaning where there is A, we put the value of A, which is 64, isn't it? So from here we now have 64 into 1 plus R cubed to be equivalent to 280. So for us to get R cubed, you take 64 inside the bracket, isn't it? Senior. Or you can divide both sides by 64, you can use whichever method, isn't it? So 64 times 1 is 64 plus 64 R cubed to be equals to 280. So we want to remain with R cubed, meaning this 64 must go on the other side of the equation, isn't it? So we will remain with 64 R cubed to be 280 minus 64, isn't it? So what is 280 minus 64? 216, isn't it? Then after that, we divide by the coefficient of R cubed to get R cubed, isn't it? We divide both sides by 64. So we have R cubed is equals to 216 divided by 64? In decimal, in fraction form. In fraction form. In fraction form, 3 and 3 over 8 it has to be a mixed fraction. That is 27 over. The reason why it has to be an improper fraction, reason being, we want r. So when it is cubed, we are going to use the laws of indices. Are you seeing that? We are going to use the laws of indices, meaning r cubed is equal to 27 over 8. 27 is the same as 3 cubed, then 8 is the same as 2 cubed. So 3 cubed over 2 cubed is the same as 3 over 2 all cubed. Are you seeing that? So we have r cubed is 3 over 2 cubed, meaning you can clearly see that r is 3 over, meaning you find the cube root on both sides, isn't it? So you found the common ratio to be 3 over 2. Are you together there? Having determined the common ratio, then you determine the 8th term. The 8th term, you simply substitute the values, isn't it? So the 8th term is going to be ar raised to power 7, isn't it? So where there is a, put the value of a, which is 64. Where there is r, put the value of r, which is 3 over 2 raised to power 7. So what do you get? You substitute those values from the calculator. We have 2187 over 2. 2187 over 2, isn't it? It's 2187 over 2, which is the same as 1093.5, which is the same as 1093.5. Then the last thing you've been requested to find is the sum of the infinite series, isn't it? So the sum of the infinite series is simply given by a over 1 minus r, isn't it? A over 1 minus r. Are we together there? So what do we have? Where there is a, put the value of a 64 over 1 minus 3 over 2. So what do you get? You have negative 128. You have negative 128. So that is how to solve such given problem. That is how to solve such kind of problems.